So let's talk a little bit about graphs and how we make them. Move this over a little bit so I can stay in the frame. There we go. So in lab, you're usually going to have two types of variables you're worried about. One is called an independent variable. The way to think of this one is this is the variable, you control this variable. So in some way, you're going to be trying to adjust this particular quantity. For example, maybe you're doing an experiment and you're interested in how something changes based on temperature. Maybe it's the mass of something. You're wondering if it's going to leave, like if it's a compound and you think that if you heat it up, some of it's going to evaporate, and you're curious about tracking that. Well, in that experiment, the independent variable is the one you control. So in the case that I just explained, it would be the temperature. I'm going to try heating up the object. So I'm making a change to it. And so the change that I'm either monitoring or making is going to be my independent variable. The other type we're going to work with are dependent. Ooh, I can even kind of spell sometimes. Dependent variables. These are variables that change based on the independent variable. So this is all about how you set your experiment up. So in this case, we're trying to change something, and then we want to monitor that change. So my object that I expect to change as I heat it up, its change in mass would be a dependent variable. So the way this comes up in a graph then, is we'll make our graph, and then the x-axis, this is the one along the bottom, is going to be where we put our independent variable, the thing we're making changes to. So that's going to be temperature. And then our dependent variable in this case was going to be mass. And so we make the measurement in a few different places. Let's say we start over here. Let's say this was at 20 degrees Celsius. And what I'm going to do is I'm going to put that all of these are in degrees C. And to make it easier, I'm going to write it a little lower so there's room for it. So temperature in degrees C. We've already got mass listed in grams. So I am not great at hand drawing these. If for some reason you really need to hand draw a graph, you would do it with a ruler, make sure everything's equally spaced to make sure things are appropriately proportioned. So let's say our markings went every 10. So we had values like this. And then let's say our mass, let's make some measurements. And we forgot my 10. Now for our mass, let's say we started at 10 grams, then went up. So 10, 20, 30, 40, 50, 60, 70. No, you don't have to write it at every single interval as long as you're consistent. Like you could write it every third interval, for example, where each dash was 10, but you wrote 30, 60, and then came up here and wrote 90. That would be okay as long as you're consistent with that. Also, most graphs are usually going to start with 0 as the bottom axis here. This will not always be the case. There could be a good reason you want to really focus in on a part of the graph. And so you're looking at something that has a variable that if it started at 0 and the value is 1,000, like let's say you're looking at atmospheric pressure and it's around 760 millimeters of mercury. And you do an experiment where it varies from 755 to 765. If you try to start at 0, it's not going to look like much of anything. So you purposely focus your graph and you change the scale so the bottom starts at 750 rather than 0. If you do that, it's important to recognize you did that on purpose. It's also important when interpreting graphs. When I look at my graph, I want to see, does it start at 0? If not, what does that do about how does that change my data and what it looks like? Is there something that this might be tricking me into thinking? For example, you might have something like you're going to look at grade point average for students, but the scale is 85 to 84, and then the change is, oh, well, it basically never changed, but it looks like it's all jagged, because, so this is sort of a little side thing, but let's say we had year versus average grade. And then we'll get back to our original graph. But let's say I start here at 84, and this up here is 85. And so this starts in the year 1996, and we go to 2016, let's say, and somewhere in the middle here is 2006. And then I look at my data points, and man, let's say it's like this. Wow, this looks really erratic. It changes a whole lot. I've got going up there. Wow, there's a whole bunch of changes. That looks huge. But it's all going around the middle of 84.5. These are incredibly small differences. But if you didn't pay attention to your graph labels, there we go, a little bit closer. So if I didn't look that this was 85 and this is 84, this could be huge. So if you had changed it and this was 70 versus 90, well then I would care a lot that it changed that much. I'm like, wow, something's not even here, something's weird. But 84 to 85, I'm like, oh, that looks really normal. So now going back to our experiment with temperature and mass, let's say it looked, we did some measurements. I'm going to plot a few points. So we made all these measurements. And there. Now we have something that represents our experiment. Now, we always have to think about why we're adding something, like these lines here. So here, in this case, I would have to think about my trend and what this information represents. In this particular case, I think it's perfectly fine to leave it as these dots here, and that it's good to look at it and notice, hey, it looks like around 30 degrees, it started to go down in temperature, and then somewhere around 50-ish, probably 53 or so, I'd go back to my data table and look, it stopped going down. So that's good to recognize, but you may remember that in a number of labs probably before you've drawn a trend line. But here I don't think a trend line would make a whole lot of sense. So I'm going to show you one and show you why I wouldn't do it. So if I went into Excel and I said make a trend line for all this data, it would look something like this. And that should be straighter. I curved it a little bit. But this line is not representative of our trend, right? This trend, it seems very clearly, wasn't doing anything. Then it changed a bunch. Then it stopped changing. So if we don't think the trend is consistent across all our temperatures, we shouldn't try to draw a trend line here. You might consider drawing a trend line just for this part here. I'll do it in another color. From this dot here at around a little bit above 30 to this dot down here, it seems like there is where all the temperature decreasing was. So there, it could be the trend line might make sense for this data, depending on what you're doing. But it wouldn't make sense to do it for all of the data points since it stopped on the left and right side. So we should be very intentional about when we're going to try to draw a trend line. And if we're not sure, just don't connect the dots. Connecting the dots means you're implying that there's some trend we should be following with it. Now, in other fields, like not science-based, like maybe you take a marketing class or something else, you're more likely to do graphs like this. And it has to do with what we're trying to say with our graphs. In many graphs in other fields, maybe it's something you're going to look at in a history class, you're trying to show this is exactly what happened, and what I'm curious about is this is the past, I'm just trying to show the record of it. This is the trend and how it changed over those years. Whereas in the case in chemistry, what we're usually looking at is we did an experiment. We're trying to come up with what is the trend that is not specific to just exactly these measurements, but in general. If we take this object of about this mass and we heat it up, what should happen? We want to do enough experiments so we have an idea that this thing, is it going to keep occurring or not? And our trend line tries to represent that. It represents a pattern we're working with. So we tend to not have lines unless we have a good reason for them being there. And a lot of times we're not going to connect the dots exactly. There will be some times where we might, and we'll talk about why when that comes up, but usually we'll be using trend lines. Most commonly linear, because we know a lot intuitively about how to work with linear equations, and we're going to work with a number of relationships in this course that are linear. Or if they're not linear, we'll do some math tricks to them, we'll show you, and we will turn them into linear relationships because it's easier for us to do some of our intuitive thought with linear relationships rather than exponential relationships, or logarithmic relationships, or other ones that we may have more trouble intuitively being able to do as much with, that if we make them linear, it's easier for us to see sometimes. So, what I want to do now is let's transfer over and look at how to actually do this digitally now. Like, what's the part of actually creating this for a lab report? So let me switch this over. Okay, so this is some data I'm working with. Let's say I made some measurements, and we looked at how fast, we set a speed to some object. So this is the dial we term. We go, this is how fast it should go, and we measured it for some time, and we looked at the distance it traveled. And so we've got, let's see, 1, 2, 3, 4, we've got 6 distances and 6 amounts traveled. And what we want to do is we want to create a graph of this data and see if there's a linear relationship. So I'm going to start by highlighting these. You'll notice I went up top how I highlight the whole column. I did that by, if you notice, I've got like this little cross looking thing, but when I go and I highlight up at the actual letter, it turns into this black arrow. And that'll let me do the whole area instead of just doing one thing at a time. And this is especially nice when you're working with data sets that might have 600 points. Now, to get to the point where I can actually do this, you have to get the data in here. So what you could do, in a lot of cases, is just copy and paste the data. So for example, you might open a file, highlight all the data points, and copy and paste. Depending on your version of Excel, you might also consider going up here to Data. And this thing that says From Text, this will let you actually pick out a file. So you'll have to go through and find your file. Let me just do that. So from text, I wasn't planning to do this, so it'll take me a second. This is going to be from lab. Let's look at a hydrogen emission spectrum. I want to import that. So you're going to get a screen that looks like this. This allows you to make some changes to tell it things like how it sorts lists. Over time, if you work with different data sets, they're going to work in different ways. Initially, if it seems okay, you can go ahead and just press finish, and it'll put things in. The one thing I will note is for a lot of the data sets you're going to work with if you're using MeasureNet, which is a tool we use sometimes, you'll notice up at the top, it has some words there. So I'm going to say my data has headers. That's a way of telling it, hey, the top line is something else. So let's see what I do when I press finish there. And I press OK. I want to put it there. And so it imported my data for me, and I accidentally already had something in there, so it shifted it to the side. So if I hadn't done that, it would have been okay. So now I have my data. And it's got a bunch of wavelengths and a bunch of intensities. So if I want to graph those, I could. So what I'm going to do, though, is I'm going to go back to our data here that I was working with. And we're going to graph it instead. So I'm going to go up to Insert. And note, if you don't have that import from data, you can always copy and paste your data. You don't have to import it directly. So what we're going to mostly use in this class, if you go to your Insert, is going to be this scatter plot. So if you're using something other than Excel, maybe Google Sheets, your goal is you usually use a scatter plot. These other graphs, things like pie charts and bar charts, it's not that they're incorrect, but they're just much less common for us to use in chemistry. We're mostly going to use scatter plots. So now I have a graph of my data. Before you do a lot of work with it, you want to check that it actually is your data. So for example, I can see that at 10, my line goes up to about 30. That's good. If it didn't, that means something might have gone wrong and I need to do some troubleshooting. So you can try so it might not be highlighting the right area. Maybe it flipped your axes. So for example, it's going across, and so it ends up thinking that 10 and 30, like this point 10, this 10 here, maybe it thinks it's connected with this 20 instead, something like that. If you're having trouble with that, there's this little thing that says switch row and column, and that will fix it, except here I can't do it because I have so many data points on the left that it wouldn't actually be able to switch it. But if it has a problem where it got your axes wrong, it might be just because you need to switch that. You can also make some changes by actually going to format the axis. So if I right click on one of these, it'll give me some options here. So for example, it might be that I don't like what these numbers are. I don't want to show 0 to 100. I only want to look at 100 to 150. Well, now clearly for this data set, that's not a good choice, right? It cut off some of the numbers. But if you had another data set where you wanted to do that, you can make these changes here. Now I'm going to stick with 0, but maybe I only want to go to 180. I don't want to go all the way to 200 because I'm fine with that being close to the top. That's fine. This will also let you change things like I can change where these lines show up. So for example, instead of being 20, I can go to 40 for my major markers. And now it doesn't have as many. So that allows us to do that. And then this will let us make other changes to things. Let's see, is there anything else I really want to change? I'm looking for one more thing So these are just all my axes options. See how we've got a whole bunch of different stuff we can do. Oh, and so this is currently for this axis here, so we can also do the same idea for this bottom axis here. So here I actually just clicked on it and it got me to it. So I can go around and make options. I can also, if I'm ever not sure, just right click on it and go back to, that's the chart area. Right click and format axis. And this will let me make changes. Like let's say I just wanted to go to 60. That'll let me do that. I click away, click enter. Now it's 0 to 60 instead of 0 to 70. And maybe I want to start at 10 for some reason. Because it started at exactly 10, I can do that. For a lot of our labs, we'll start at 0, 0, unless there's a really good reason to otherwise. Now, I want to make some other changes that I want to work through. So for example, I don't like this title. I'm not going to put the unit there. I'm going to put it somewhere else. So I'm going to put distance traveled by model object. Now, this is because this is an experiment I made up of my head while I was making the video. it will depend on what you did in lab, what would make sense to title it. For example, maybe it's calibration of a thermometer. You would title it calibration of a thermometer. We also need to go through and add some axes titles. So I can do that by clicking this green cross here and clicking axes titles. Again, if you're using a different piece of software, it might be in a slightly different place, but you can search for that. So you want to do that. And then this is going to be my y-axis was distance traveled in meters. And then my x-axis was my speed setting in meters per second. You want to make sure that you have the correct thing on your x and y-axis, because it's possible that you could have written this the other way, and then suddenly you would have distance traveled on the x-axis and speed on the y-axis. And this wouldn't make sense because I'm telling you, you're controlling the speed. You're setting that dial, and then you're measuring the distance traveled. So you want to make sure you choose options that do it in the correct order that you would want. So let me check one more thing. What can I do on that? That's good enough. So this will give me a graph. Now, one thing to notice about this graph, as it's currently written, is that it's inside of this Excel document. I don't want you to try to print out this whole thing and not just to take a screenshot of this. It's easier if it's formatted separately inside of a word processing tool. So what you can do is you can click on your graph and then you can copy it. For example, I press Control-C, whatever it happens to be in your piece of software, and then I'll open a blank word processing document, and I can press Control-V or whatever key you use to paste, and I can put it right here. And then that will let me do things like resize it. And this way I can turn in the graph on its own. And then I can make more graphs if I need to and put them beneath it. Or I can put it inside of a document this way. Now, this doesn't just work for graphs. So in this class, you'll be turning in documents digitally sometimes. And maybe the easiest way for you to do that was you took a picture of some of your work. Rather than trying to turn in 6 different picture files, you can put them all inside one report file that makes it easier to format. So for example, I'm going to make a new page. Let's say I wanted to put 2 pictures in that I had of my lab report. So go up here to Insert, and I'm going to go to Insert Pictures. It might look slightly differently on your word processor, but there'll be something about inserting images. Then I'm going to choose 2 files. This is actually something I've done for test creation. This is my equation sheet. So I copy and paste it. Now I've got a picture. I make a new page, and I can do another one. So I'm going to also insert a picture of the periodic table. Hey, I have 2 pictures now, and I can see they're both there. So if I turn this in, it all turns in as one document. Now, maybe my picture's rotated the wrong way. I want this periodic table to take up the whole page. So I'm going to rotate it 90 degrees. So you'll be able to find some type of rotate option on your word processor. And then I'm going to change the size. So I'm going to make it so it fits the whole page. And so now that's a way I can make an adjustment. You may notice I've done a number of things in this lab where I've done things like inserted images, or I've made a graph in Excel. And maybe some tool you're working with doesn't feel like it matches quite up. You're like, mine doesn't look exactly like that. Well, the first way you can try to fix this is you can play around with your tool some. That gets pretty helpful. Honestly, I figured out a lot of this, but I just went to different tabs and trying things out. Having said that, I know sometimes it can be really hard to find an option. One of your best things to do is to use some type of search engine. For example, Google. Search, and when you're doing a search, try something like either Excel, if you're using Excel, Google Sheets, or Word, or whatever tool you're using. Put that word in, then put your addition. So for example, if you're using Office 365, I would put Word 365, and then literally type in your question, like, how do I rotate an image? And then look through the searches. You're very likely to find videos or text descriptions that can help you with that. And that can help a lot with being able to use these tools. And then once you get used to them and you've done these things a few times, you'll know how to do it. So if you're unsure, that's an option. And then a final option is you can ask me if you've gotten to something you just are really stuck and you're not sure where to go. You can also ask me questions, you can also ask your friends. It could be somebody else working on it can help, but I am perfectly willing to also answer questions via email.